This is a demo of Microsoft's Visual Studio Team Services. The demo specifically will be an end-to-end DevOps type scenario for a Java web application, and we will be showing a lot of the popular Java features and capabilities of Team Services. You can interact with our Java ALM team on Twitter at Java ALM, and you can also check out our website at java.visualstudio.com. Today is May 3rd, 2016. I'd like to start by reviewing what are you going to see in this demo, and I apologize, I know this is a busy chart, but we're going to be showing you a lot of different features today, and we want to start by kind of summarizing what we're going to be showing. I'm going to show you an AngularJS, JavaScript, Java app. It's written in all three of these. It's running on an Azure Linux Ubuntu VM using Tomcat. We're also going to show it running on AWS as well, and I will show you that in just a moment. The app is actually instrumented with our application insights, which is our metrics package from Azure, and it'll be tracking the metrics and events that are occurring within the app. I'm going to show you an integration of team services with Trello using a technology known as service hooks or webhooks. I will also be showing our system, specifically our Git repo server capability integrated with Atlassian Sourcetree, proving that we're using standard industry Git and SSH. I'll also be showing you some Kanban boards, work item usage, also known as backlog stories and tasks, and also bug tracking. We're going to be using Java contextual searches to help us find where to make some modifications in a particular repo. Then kind of the meat of the demo is going to be the day in the life of a Java developer using Intellij IDEA. So I'll show you our Intellij IDEA plugin that will actually from within the Intellij IDEA application, I'll clone a repo, I'll create a branch, I'll make some changes to that branch, I'll do a local commit. When I do the local commit, I'll actually associate some stories and tasks to it, so we have end-to-end traceability. And then I'll issue a pull request, and then eventually I'll complete that pull request. But before I complete the pull request, we're going to actually see an automated hosted Windows build of the changes I made. The Windows build, like I said, is hosted. It's a set of machines that we provide to developers to use. So you don't have to set up your own build machine if you don't want to. We're going to be using Windows, building under Java 1.7, and we'll actually build the application using Maven. And as part of that, we will execute and present the results of your JUnit test, and we'll show you some code coverage using Jacoco. Assuming that pull request build succeeds, I'll complete the pull request, and when I complete the pull request, merging the code back into the master branch, it's going to kick off a production build on an Azure Linux VM that I have set up. So it's no longer using the hosted build, it's actually using a specific Azure VM, a Linux VM that I set up specifically to support continuous integration build using our build vnext agent. It's also running Java 1.7, but instead of using Maven, I'm going to use Gradle here just to prove that we can, because we support Maven, Gradle, and Ant builds. I'll also execute PMD and check style static analysis just to show you those capabilities. After that build completes, we have continuous deployment set up so that we'll actually deploy the Java war file to an Azure Linux VM that is part of a pipeline. The first stage of that pipeline is a test or a QA machine. On that test or QA machine, once the deployment occurs, we'll run a set of automated Selenium tests. Selenium basically is a test framework for testing web apps, and all that really will do is make sure that the app comes up and displays a title. It's a very simple test, but you could make it more complex if you wanted. Once those tests pass, then we'll start an automatic parallel deployment to an Azure Linux VM in production, and also an AWS Elastic Beanstalk VM. Both of those are Linux running in production. And then we'll prove that everything works. We'll verify on all three servers, the test server and the two prod servers, that everything is working right. Once we do that, we'll go in and complete our work items that we were assigned. We'll go back and take a look at Trello to make sure it's been updated. And basically, I'll look at some metrics to make sure all of our metrics look good from our deployment. So it's kind of an end-to-end DevOps Java scenario. So having said that, let's look at our application. I have it here running. Excuse me. We have 3 instances of it running. We have a DSpace-test VM, which is our QA environment. You can see the application is a very simple application. You see a sun fly by, and then 2 planets will come by as well. There's one of the planets there. And then I think we have Saturn coming up there. The application is very simple. You can change the speed at which you fly through. You can change the number of stars. So very simple. But this is our test environment. We also have it running in production in Azure on a Linux VM. Same application, same behavior. And we also have it running in Elastic Beanstalk on AWS in an Amazon Linux machine. One thing you'll notice is that Earth is not here. So one of the tasks that we're going to take on today is to be adding Earth back into this simulation or this web application. So that's the web app. Let's look over at the metrics for this web app. We're using Application Insights, which is an offering from Microsoft Azure. And here we see some of the performance metrics. You can see the number of server requests that's happened in the past 24 hours. Over here on this graph, the number of failed requests. And over here you can see different timetables, how much this is some usage that the application saw yesterday in production. Here's the usage from today. We've had 12 unique sessions, 10 of which came from Windows, 1 came from Linux, 1 came from Mac. So we'll talk a little bit more about these metrics later. But the scenario basically is that I'm in an enterprise, and we have two distinct groups in the enterprise. We have the developers, and we have a set of program managers or product managers. And the PMs kind of complain that they never hear from the developers when they do their production deployments, and they never hear when features are implemented. It's just a typical enterprise communications breakdown. So to solve that problem, we've made a recommendation that we use Trello, a third-party app, and we've created 2 boards in Trello. We've created a board to talk about and to track when production deployments occur, and we've also created a board for when features are completed. And so we have integrated our service with Trello via service hooks or webhooks is a technology we're using. And when deployments are successful, we'll automatically send the data over via the service hook, and we will create a card under this production deployment board. And when we move features to the completed state in our Agile planning tool, that will automatically populate these completed features. And so that's, we'll come back and look at this board later. But let's first just go into the system, and so I'm logged in here as the persona of Raisa. Today I'm playing like I'm Raisa, and I'm a Java developer within an enterprise. And I log in. My repo name is raisajavademo.visualstudio.com. You can select this name. I've selected Raisa Java Demo. I'm going to go into this deep space project, and it will bring me into our tool. And so here we have team services running in the cloud. And I'm going to go quickly through kind of the sections that make up our product. We have the code section. The code section is where your code resides. You can see the repo itself. You can actually drill down into the code, and you can actually open a file here if you want. You can even do very simple editing. You'll be editing whichever branch you're on, which right now I'm in the master branch. You can view the branches you have. You can view any outstanding pull request. You can check the history of a file. That's the sort of things you can do in code. You can go to the work section. The work section is your Agile planning section. So this is where you track your stories, your tasks, your backlog, and bugs. Here I have a Kanban board configured to not only show me the tasks, but also to show me bugs. And so that's the feature I have turned on so that I can actually see bugs with my task. And I can see here that I have 2 things I need to go do today. You can also look at it in a backlog mode for more the Scrum type planning. But I'm going to use this Kanban board today. The build section, think of it as your continuous integration section. This is where you put all your build definitions. This is to do all your builds. We support many different tasks and under build definitions, and we can get into that a little bit later. You can see I've had some successful builds with the green arrows, and I've also had some failed builds here with the red X. The test section, I'm not going to demo today, but basically this is a section of our product that lets you track manual and automated testing. And then the release section lets you do deployments. It does release management and lets you do deployments. Here you can see I've had a release definition that used to only have 2 stages in the pipeline. You can see the green, it means the stage was deployed successfully. Red means it failed for some reason. I've modified this release recently, 2 or 3 days ago, to add 3 stages. I have a stage for QA or test, which most recently succeeded. I have a stage for production deployment to Azure Linux VM, and I have a production to AWS VM. So we're going to go through all this, and I just wanted to kind of familiarize you with that. So I would start the day, let's assume I'm the day in the life of a Java developer and on an Agile team. I'm in an Agile team, and I'm going to use a Kanban board. So I come to work and I say, okay, what do I need to do today? I can see that I have 2 tasks assigned to me. One's a bug, and one is a story. So I'll open the story, see what it's about. It says I'm supposed to add Earth to the flyby planets. We noticed earlier that Earth was not there, so we're going to go in and add that. So I'm supposed to add Earth to the Java class image service. I'm going to copy that because I'm going to use that later to actually find where in the code I need to make the change. It says also to remember to fix the unit tests. And so I need to not only change the code to include Earth, I need to make sure that I modify the unit test so that they don't fail and break my build. So I'm going to do that today. And then the other one is a bug. I go in here and look at it. I know it's a bug because it's got this red border. It says I have a warning in check style that I'm using a wildcard form of import. And so I'm going to fix that. I've arranged the demo so that these changes all happen in one file just to make it quicker and easier. So the first thing I'll do is move these to active because I'm going to go work on them. And now my team, if they come in here and look at it, and they can see that I've got those tasks in progress. And the very first thing I'm going to do is go find where I need to make this modification. So the feature to add Earth said I need to search for the class definition of image service, and so we have here all the different ways and filters you can search by, and we have full Java contextual searches that'll go across all repos and all projects. And so I can say class : image service. I want to find that. This will find me only the class definition. So if image service is called 1,000 times in all of my repos, it's not going to pollute my search by giving me all those. It's only going to tell me where the class definition is, which is where I need to go make the change. So see here, class definition is under source main Java. I follow this path right here, so now I know where it's at. If I wanted to, I could actually edit this file in place. We do have the ability to edit directly here. I would be editing the master branch because that's what I'm in. But instead of doing that, I'm actually going to demonstrate how we would clone this repo using our Intellij plugin that we've written. We have plugins for Intellij. We have a plugin for Eclipse, and we have a plugin for our Visual Studio Code editor. So let me go over to the code section, and I am going to clone this repo, and I'm going to clone it my favorite IDE. You can see here we could clone it in Visual Studio. I could do Android Studio if I'm doing mobile development. We have things like Intellij, which is the one I'm going to use. We have PHP Storm. All of the Intellij products are here. So I can just clone this in Intellij. I'll click that. On a second screen on my computer right now, I've got the Intellij IDEA Ultimate version 14 splash screen coming up. In just a moment, it should ask me to maybe enter a password or keep going. We'll see. But I still have the splash screen. It's still loading. All right, and so now it's going to come up and open here. So let me close that background thing so we don't get confused about what's going on here. So here I have Intellij IDEA. It's asking me to enter a master password. So do that. And now I want to do a checkout. So this is actually our plugin running inside of Intellij. One surefire way to know it's our plugin is we have these feedback capabilities. So you can send a smile, send a frown from all of our different components. So I want to clone the repo. I need to give the directory name a unique name. So I'll call it demo 531 just to make sure it's unique, and I'll hit the clone operation. So our plugin now is connecting to team services using our REST APIs, and it's doing a clone operation across and using Git. And I want to say yes here. And then it's now cloning it. It wants to know what type of project to create inside of Intellij. I want to create a Maven project. I need to search for projects recursively because I know I have more than one project here. I actually don't want to use the UAT environment. I want to use the production environment next. And I'll go ahead and finish that. And so now we're cloning and we're opening a project inside of Intellij. All of this within the IDE. I'm now kind of away from our web interface. So it's resolving dependencies, and we should now be good as soon as the progress bar says. So still building the project. Okay, now. So the first thing I want to do as a developer is I don't want to edit the master branch. You can see here I'm in Git, I'm in the master branch. And so what I want to do is create a new branch. I'll call this feature for demo. We'll create a new branch. Now I'm editing in the feature for demo branch here was created. Now I can safely go in and find the code. It was under source. Main Java image services where I wanted to do it. So I'll double click there, open this file. To add here, I need to come down and find this code here for Earth. If I uncomment out some of this code, okay, that should do everything I need to do to add Earth into my web app. But if I remember correctly, one of the things that my task or my story said was to make sure to go change the test as well. So I need to go over to my unit test and open my test file here. And then to make this work, I need to now tell it instead of 3 images, the sun and 2 planets, comment that out. I need to tell it that I have 4 planets, so my test will pass. And then I need to come down here and comment in these lines, which are actually my test. And so, okay, now I've updated my test. So hopefully if I compile, if I haven't made any mistakes, my task or my story should be complete. But I also had a bug reported that I was using a wildcard. And so if I come up here, I can see it here. I've got this import here using this wildcard. That's not best practice. And so I want to go in here, comment out that line, and actually comment in the lines that call in the includes or the imports by specific names that I want to use. So now I should totally be done. So what I want to do now is actually go into my version control menu, and I want to commit the changes here locally. So when I do the commit changes, again, our dialog comes up. This is your typical IntelliJ dialog for commit changes, but we've added a feature here so that I don't need to remember the number associated with my task, like task 579293. I would never remember that, so I can actually just click on this little icon. It'll go query the server, and it'll tell me what tasks are assigned to me. I can see that I have these 2 active, which are the ones that I'm working on. So I want to take these 2 story, or this one story and this one bug, and I want to associate it with this commit so people know why I made these changes, and then I can do the commit. So the commit's now made locally, and then you can see down here 2 files were committed, and I can actually go to my pull request section. If I had any pull requests on the server that were assigned to me, they would show up here. If I've had any requested by me, they would show up here. I don't have any outstanding, so I need to create one. And it knows basically from my commit everything it needs to know, that these 2 files changed and that these were the stories that are being worked on. So I can now just say create pull request. So it's pushing the local branch up to the server, as it says. And now a pull request will be created on the system. And if I go and refresh my pull request, you can actually see requested by me now. It knows that I have a pull request outstanding. And then if I want to get to that pull request, now for the first time I'm going to leave the IDE and go back to our web interface for team services. I can come over here and I can see here is the change I made. Here's the pull request. And I already know that I don't have any merge conflicts. And I have some active rules associated to this branch. And some of the branch rules say I need to at least get some reviewers to look at it before I'm allowed to complete the pull request. And I also need to do a build. So it's actually doing a build right now. So if I go over to the build was automatically kicked off. This is kind of our PR build, our smoke test build, make sure I didn't break anything. This is running on a hosted build on a Windows machine, and it's going to run Maven. So this takes a little bit of time because I've got to wait for an agent to be allocated to me. A virtual machine type thing has to be spooled up and to run my build. And so while that's going, I'm going to switch back over to PowerPoint and show you a diagram that basically walks you through everything I'm showing you today. So I kind of showed you textually what it is. Now I'm going to describe it. So here's our Visual Studio Team Services. We have all these different sections we went over: code, work, build, test, and released. As part of our code, we have our hosted repository, this deep space repository here using Git. I've shown you how to hook up to this using IntelliJ IDEA. So we actually said I wanted to do a clone, which automatically kicked off my IntelliJ IDEA application, and then we did a clone operation. I made some local changes, and now what I've done is I've done a pull request back up to the server. That pull request has kicked off this build over here, this PR build, as part of my build system, and it's building on a Windows hosted agent using our build vnext agent, and it's under Java 1.7 and Maven. When that completes, I'm going to come back over to code, and I'm going to complete the pull request. And when I do complete the pull request, that will merge my changes from my branch back into master, which will kick off a CI build in production. That CI build is going to use a Linux VM that I've stood up in Azure. It's going to build using Gradle, our build vnext agent in Java 1.7. It'll also run JUnit test and publish the results and run a JCocoa code coverage. And then after that build is successful, kind of our test release system will pick it up, and the test system will run a set of Selenium tests. We'll deploy to a QA environment or test stage the application. It will run it, and a set of Selenium tests will be run against it to make sure that it's actually is running and that there are no problems. And then once those tests succeed, our release system will pick it up and deploy in parallel to two different environments. One environment is an Ubuntu Linux VM running in Azure, then another one is actually running in AWS. And so it'll deploy to both of those systems. Once it's deployed to both of those systems and we go run it again, then the telemetry from those two production boxes will feed into Application Insights, which is a hosted telemetry system. And also part of the release, at the time we have a successful release, we will stick a release annotation into our metrics to mark that on our graph so that we know when the release took place in case the metrics start going in a different direction than we would hope. And so this is kind of the end-to-end demo. The other thing I want to show you too before I forget is actually I want to show you Atlassian Sourcetree hooked to our code repository to show you that we are standard Git. So I can actually bring up this is the SourceTree application from Atlassian. You can actually look and see where it's hooked to, the repository settings. You can see that we're using SSH to hook to this Race of Java demo repo that I talked about. And since I last did this, it's actually gotten some more requests, and so I can actually do a pull request using this, and it's using SSH and standard Git to go out to our repo. And it actually brings it down. So you can see all the changes here that have been made over the past few days by different people. And so this, again, just shows you an industry product that's not from Microsoft connecting via standard SSH and Git to our service. So this was also just showing you that. So now we can walk through kind of where we're at in a demo as we've made these changes. This PR build should now be complete. I've talked long enough. And so then I'm going to go complete the pull request. So let's go back over to our system. The build is successful. If we look at the build real quick, just to make sure things went okay, we see our 10 unit test all passed, and our code coverage is better than 85%, which we'll just assume is our team standard. And so again, this is just Cocoa and show some Java capabilities with our build system. So now I'll go back over to the coding section. I think it's where I was. Let me just go there here. Go to the code section. And I can go under pull request, and I see I have this pull request here, and it says the build succeeded. There were no merge conflicts. We don't have any reviewer comments. We could put in some and say, hey, it looks good, but I'm going ahead and complete this pull request. When I complete the pull request, it's going to merge the branch, my feature branch, into master. That's now been completed successfully. So if I go over to my build system, I should see that a production build has been kicked off, as I showed you in the picture. And if I look under queued, I should see a build, and there it is. And so if I watch this, I can actually watch it build. This will execute faster than the hosted build because the machine does not need to be created or allocated. It's already sitting there waiting. And so you can also see we have Sonar Cube analysis enabled here. And so that's another feature we have is Sonar Cube. You can also do PMD check style analysis. And so our production build is occurring. You can see the history of of the previous builds. The last build was successful. You can kind of get, it takes about 99 seconds to do this, and so we're at 50 seconds, so we got about 49 seconds left. You can get some useful information here. And so it's proceeding with the build. And again, to remind you, once this build is successful, then we will deploy to our QA environment, run a set of Selenium tests. If those pass, we will automatically promote and deploy to our production environments. You can see here, I think I've told you that this is actually running a Linux OpenJDK build machine that I set up. We're doing a Gradle build as opposed to the Maven build that we used previously in the PR build system. So it's proceeding, and it's probably going to now take a few more steps. Now doing the code analysis report, and it's uploading some files, and we're now publishing the build artifacts. And so it's almost done, and in real time, still publishing. Okay, and now the build has succeeded. So if I go over to my release management, what we should see is the three-stage pipeline that's showing all gray across the board. Yep, the blue, the test one's already started, so I didn't get here fast enough. So this has kicked off a release of these different environments. So the QA test is actually in progress. I can open this up, and I can watch it do its deployments. I can look at the logs. So it's currently doing the test environment. This will go very quickly. It'll deploy to the Tomcat test environment, then it'll run. It's already done the deployment. It'll get ready to run the Selenium tests here in just a second. And then as soon as those Selenium tests are here to go, they're kicking off now. And as soon as they run, it was successful. That stage is now complete, and the app is now deployed to our QA environment. It'll automatically refresh, and it starts a deployment to both of these production environments in parallel. We have one to Azure and one to AWS. It's kind of a race to see which one will finish first. I think usually the one that Azure finishes a little ahead of the one to AWS, but sometimes got a little bit of a race condition there. So they're both going off, and they're both deploying in parallel. And so the reason, again, this is automatic is because I've configured it that way. You could have it so that after the test environment, we actually have to do a manual approval. But for the purposes of the demo, I wanted to show a full CI/CD demonstration. So as this, okay, the one to Azure is complete, and now we just wait for the one to AWS to complete. And again, this is happening from our Linux build VM. So okay, everything's now complete. I want to go back. I didn't want to miss this, but I want to actually go back to my build system, and we can see a few things here. The completed one, the last one that we did 2 minutes ago, I can actually open that up, and we can see our test results. We have actually 20 tests configured here. I didn't have code coverage actually turned on, but I did have static code analysis turned on for this Gradle build. You can see here that check style found one problem. If I had looked here before we started, it would have found 2 problems, but we fixed one of them. And so you can see your static code analysis here. Now if I jump over to the release build, I want to make sure we get the release number. Release number is 146. So the release that just went out was release 146. So if I go now to production and actually start with our test app, and if I do a reload here, if I reload the app, so this is our QA environment, we should see the sun. And then if we did everything correctly and our deployments went out, we should see the earth, and there it is. So our QA environment looks like it updated correctly. We can go to Azure and do a reload of the app here. And we can see the sun. And then next should be earth, and there it is. So it's actually running in production in Azure. Now if I go to my Elastic Beanstalk and do a reload, there's the sun, and then here's the earth. And so all 3 of our stages was correctly updated with our feature fix. And so I'm pretty confident now that I can come back into my tool, and I'm going to go over to my work area, and I'm going to say that was a good day of work for me. So I'm going to close those 2 tasks. Now, closing those 2 tasks is the trigger for me to send information via the service hook over to Trello, and the fact that we had a successful deployment. So if I go over to Trello now, we now say we have a new version in production. Build 162 has now been deployed to production, and it gives the date and the time. So the PM team now is fully informed of what happened, and they also can see what's kind of in that production. They can see that there's a user story. We added Earth, and we fixed the wildcard for Java imports. Not that they care, but this was a bug. And so all that was done automatically via service hooks. So if I go to my metrics now, and if I refresh my metrics, we should see this little icon right here, this blue one. If I hover over it, it'll say that release 146 occurred on May 3rd, 2016 at 2:27 p.m. Eastern Standard Time. So if my metrics were to start going downhill or start doing some unpredictable results, I could trace it back to the actual release. And if I go to the release, I can trace it back to the build. And if I go to the build, then I can trace it back to the pull request. And from the pull request back to the commits, and from the commits back to the developers that made them, and back to the work items that they were working on. We have full end-to-end traceability through our system. And so this is basically the demo. Thank you for your time and attention.